fully inscribed in a trapezoid ABCD, as you can see in this diagram, such that this side length CD is 16 units. This side length AD is 18. And finally, this side length BC is 14. And moreover, this segment AF equals to this segment FB. In other words, F is the midpoint. And furthermore, these angles, this angle, and this angle are 90 degrees each. And now our task is to calculate the area of this green shaded region. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. I am going to draw some auxiliary lines. So therefore, I have connected this point E with these vertices A and B. And now let's make an observation. We can see that this segment equal to this segment, and this is a 90-degree angle. So therefore, this side length AE is going to be congruent to this side length BE. Let me call this AE side length as lowercase c. Likewise, this another side length BE as lowercase c as well. And here's our next step. Let me label this side length as x units. We know this whole side length is 16. So therefore, this segment AC is going to be 16 minus x. And here's our next step. Let's focus on this right triangle ADE. And we are going to use the Pythagorean theorem on this triangle. And here's our Pythagorean theorem, a square plus b square equal to c square. Let me call this longest leg as our side C. I'm going to call this side lowercase a and this lowercase b. Let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is x, so this is going to become x square plus b is 18 whole square equal to c square. Let's go ahead and simplify, so we can write x square plus 324 equal to c square. Let me go ahead and call this equation as equation number 1. And now let's focus on another right triangle BCE. And we are going to use the Pythagorean theorem once again. And here's our Pythagorean formula once again, a square plus b square equal to c square. Let me call this longest leg as our side C. I'm going to call this side lowercase a and this lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is 16 minus x whole square plus b in our case is 14 whole square equal to c square. And now let's recall this famous identity. A minus b whole square could be written as a square minus 2ab plus b square. I'm going to apply it on this binomial. So therefore, this is going to become 256 minus 32x plus x square. And then 14 square is 196 equal to c square. Let's go ahead and combine these like terms. So therefore, we can write this one as x square minus 32x plus 452 equals to c square. Let me go ahead and call this as our equation number 2. So therefore, we are ended up with this equation 1 and 2. And now let's go ahead and compare these two equations. We can see the right hand sides are c square. So therefore, we can equate the left hand side as well. So therefore, I can write x square plus 324 equals to x square minus 32x plus 452. And now we can see this x square and x square is gone. Let me go ahead and move this 324 to the right hand side, and at the same time I'm going to move this 32x on the left hand side. So let's go ahead and write it down. So I can write 32x equals to 452 minus 324. Let's go ahead and divide both sides by 32. This and this is gone. So therefore our x value turns out to be 4 units. So therefore our this segment
सोशल मीडिया एक ऐसी जगह
turns out to be 4 units. So therefore our this segment DE is going to be 4 since x equal to 4, and this segment EC is going to be 16 minus 4 is going to give us 12. So therefore our this segment DE is 4 and this segment EC is 12 units. And here's our next step. Let's focus once again on this right triangle BCE. And now let's go ahead and calculate the area of, now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, our base is 12 and our height is 14. So let's go ahead and calculate the area of this triangle BCE. So I'm going to call area equals to a half times base is 12 times height is 14. And if we simplify the right hand side, this turns out to be 84. So therefore the area of this triangle BCE turns out to be 84 square units. And here's our next step. Let's focus on this right triangle ADE. And now we are going to calculate the area of this triangle ADE. And now let's recall the area of a triangle formula once again. Area equals to a half times base times height. In our case, our base is 4 and our height is 18. So therefore the area of this triangle ADE is going to be a half times base is 4 and height is 18. So therefore area of this triangle turns out to be 36. So therefore the area of this triangle ADE turns out to be 36 square units. And here's our next step. Let's focus on these two right triangles AFA and the other right triangle BFA. And we can see that these two right triangles are congruent triangles according to side congruency theorem. Since these two side lengths are equal, these side lengths are congruent, and this side length is in common. So therefore we conclude that their area is congruent as well. If I call the area of this triangle as S, then the area of this other triangle is going to be S as well. And now let's recall the definition of the trapezoid. Sometimes we call it trapezium. A quadrilateral with at least one pair of parallel sides. Therefore, we conclude that this quadrilateral ABCD is indeed a trapezoid. So the area inside this trapezoid ABCD is going to be the sum of these individual areas, 36 plus S plus S plus 84. So let me go ahead and write down 36 plus area S plus area S once again plus 84. So therefore the area of this trapezoid ABCD, if we combine these like terms, is going to be 120 plus 2 times S. And now let's recall the area of a trapezoid formula. Area equals to height h times a plus b all over 2. And in our case, our height h is 16, our base a is 18, and our base b is 14. So let's go ahead and calculate the area of this trapezoid ABCD now. So this is going to be our height is 16 times our a is 18 plus other side is 14 all over 2. And if we simplify that thing, that is going to give us 256 square units. So therefore our area of our trapezoid ABCD turns out to be 256, and furthermore our area of trapezoid ABCD is equal to 120 plus 2 times S. And now we are going to compare these two equations since both belong to the area of the trapezoid. So I can equate these right hand sides. So therefore I can write 120 plus 2 times S equals to 256. And now let's subtract 120 from both sides. This is gone. So therefore 2 times S turns out to be 136. Let's divide both sides by 2. This 2 is gone. So therefore our area S turns out to be 68 square units. So therefore our this area S turns out to be 68 each. And here's our final step. Let's go ahead and calculate the area of this green shaded region. So we are going to simply add these two individual areas, 36 plus 68. So therefore the green region area is going to be 36 plus 68. And if we add the right hand side, that is going to give us 104 square units. So therefore the area of this green shaded region turns out to be 104 square units. Thanks for watching, and please don't forget to subscribe to my channel for more